Hello everyone and welcome to Unit 3b, yay, making some progress. What we're going to continue to do is talk about associations or relationships in quantitative or numerical data. Unit 3a, we talked about categorical data, so we're kind of moving on a little differently. Again, I actually did have a typo on your page. We're going to be talking about associations in quantitative data. On accident, I typed the wrong thing there, so make sure it says quantitative. All right, let's go look at how we would figure out if there's a relationship. Again, up here, make sure this is quantitative data or numerical data. Associations in quantitative data. So our goal for this unit is to determine whether there's a relationship or not between two quantitative variables. And how we're going to do that is we are going to look to make sure that there is a clear pattern in the data. So in this unit, we're going to be looking at scatter plots a lot. So we'd first look at the scatter plot and be like, see what's going on. We've talked about having our explanatory and response variables, so we'll kind of see those. And the whole thing is to go see if there's patterns. So there's different patterns that you could see. You could see that they look linear or curved or clustered or random scattered. And so once we see that, we can kind of comment on how close they are. So we'll look at the strength of our pattern we can see. Some of them will be really weak, some of them will be really strong, like really look linear, kind of look linear, really looked curved, kind of look curved. So we're going to comment on how strong that they are. We're also going to be talking about the direction that they're kind of going in. So we would say something has a positive direction if you were looking at a set of data. As you increase through like the x values, as you look at the x values, if the data is also the y values are going up, we would say that that has a positive direction. Think about like the slope of a section of data versus if you were looking at a set of data and as the explanatory variable increases, the response variable decreases. Think about having a negative slope. That would kind of tell me that there is a negative direction happening within that data. And we would say there was kind of no direction if there's kind of no slope, or you just kind of have like a blob of things happening. The idea of outliers are not going away, so there'll always be points that don't quite fit in the overall pattern. So we have outliers, which we've talked about before, and these are going to be points that are like in your data. So imagine that you had, I don't know, like a class set of test scores, and this is kind of maybe what they looked like, but then you have a point that's like up here. So maybe this is like hours studied and then a grade that they received. And you can kind of see there's like a trend. As you studied more, you tended to do well. But we have the one person that didn't study very much, but they still did really well. We would consider them an outlier. So we would say they stand out in the vertical direction. They have an unusual y value considering its x value. Like you would figure them to have done worse considering they haven't studied very much. Versus a high leverage point would be a person that maybe if you're still thinking hours studied for a test and then like your grade, it would be somebody that most people probably studied 15 minutes to an hour, so most people are in here, but then maybe you have like the one person that studied for some reason like 10 hours and they're like way over here. We would call them a high leverage point because they're standing out in a horizontal direction, so they have an unusual x value in comparison to everyone else. So whenever we are going to look at some data, these are some things that we're going to kind of be thinking about. What does the data look like? Kind of like the shape from our first unit. How could we describe it? Still kind of that shape. Is it a strong shape? Is it not strong? What direction are things going in? And we're looking at those unusual points. So whenever we write about a relationship, we're going to kind of comment on the things that we see. See if there's any oddballs, and then tell what we learned in the context of that situation. So if you go over here to the next page, we're going to look at two sets of data and see if we can talk about the relationship that we see. So looking at the very first one, we have an example over here. It says, a study on test results and hours spent studying had a correlation of R equaling 0.6. For right now, if you want to highlight this correlation of R whatever and this residual plot, and just maybe make a note, we are going to be learning about this later. We'll learn about later. This is going to help us later make a better write-up for the relationships we notice. It'll give us further support to what we're going to say. But for right now, let's just look at what we see in the scatter plot. It says a study on test results and hours spent studying is below. The data and residual plot are provided. So let's just look at our data. It says describe the relationship. So the very first thing that we're going to want to look at in our scatter plot is the form. So when I look at this, to me, it kind of looks linear, right? Pretty linear for the most part, actually. And then we appear to have these points that are a little bit maybe further out of the trend than everyone else. And so when we start writing, we're going to talk about strength, form, and direction. So I'm going to say there is a strong, positive, linear relationship between hours studied and test grade. So again, just to kind of see, I've got my strength of what I'm looking at. It follows that pattern pretty well. It's in that positive direction, right? As one thing goes up, the other thing's going up. And I did give a form. So strength, form, and direction are all there. Notice that I have put in some context about what we're actually talking about. Other things that we want to talk about are those high leverage points or outliers. And to me, when I look at this, we have two outliers. They fit in the data overall of how long they've studied. They have unusual Y values. So I'm going to comment on that. There appear to be two outliers. One at, I really don't know, halfway would be like here, so maybe we would say at 0.25 and 100, and the other one is at 1, and their test score, I don't know, is maybe like 40. I'm just not the best at estimating these things right now. The other one's probably at like 90, whatever. So yeah, so there appears to be two outliers. So again, I've talked about the strength, form, and direction. I've kind of gotten those data points that are looking good. And then at the very end, we need to bring context back into this of talking about the relationship that we've seen. And so if I was to comment on what I know at this point, I could say as the hours, maybe I won't say that. We'll say as you increase the number of hours studied, people tend to get a higher test grade. And remember, we talked about relationships, meaning that one thing definitely doesn't cause the other. So you'll notice I said tends to in there. Just because that you studied more hours doesn't mean you're going to get a higher test grade, right? But that's just kind of the trend. So you can kind of see how we've kind of gone through all of these, talked about strength, form, and direction. We've mentioned outliers, and I've said what we've learned about like the situation. So I'm feeling pretty good about that. Let's try one other one to make sure that we're in the clear, and we're going to practice writing about these tomorrow in class as well. So it says the data below had a correlation coefficient of 0.25. And again, maybe just like in the top, we're going to come back to what that means later. Don't worry about it. And it says describe the relationships between the variables. So let's just go look at what the variables are down here. It appears that we have speed and your gas mileage. So there does appear to be the trend here as we go through the data. As you increase your speed, it appears at a certain point that you're increasing your gas mileage to a certain point. But then once you get going too fast, then it appears that your gas mileage actually goes down. And so we're going to comment on this. So I would say that over here we do kind of have this trend where it's kind of curved in nature, kind of looking like that. I would say that that's also a pretty strong relationship. We'll talk about what's strong and not strong or whatever later, or weak, and we'll spend quite a bit of time on that. So for right now, I'm going to say that there is a strong curved relationship between speed and gas mileage. Awesome. So notice that I have talked about the strength of how well it fits what I'm looking at, and I have also said the form. Now, I did not talk about direction, so we're going to spend a little bit of time talking about that now. To me, it appears like if we look at this, where would this be? Kind of looks to me that the relationship looks like as the speed increases up to like 50 miles per hour, the gas mileage also increases. But then after that, as you speed up past 50 miles per hour, it appears that the gas mileage decreases. So we would say there is a positive relationship between speed and gas mileage from 0 to 40 miles, or we'll say 50 miles per hour, and there is a negative relationship from 50 miles per hour to 100 miles per hour. So I've kind of commented on those directions of how it kind of switches when we're looking at that. So I've talked about strength, form, and direction. We want to comment and see if there's any outliers or high leverage points. To me, none of the data values are really that crazy outliers, but there is this point that's a little bit further than the rest of them. And when you have something that's kind of out farther than the range of everything else, this is kind of spanning from 0 to 80. That one's over kind of at 100. I would say that that one could be considered a high leverage point. There appears to be a high leverage point at, and I've kind of covered it up so it's kind of hard to see, but we would say maybe 105. And so I've mentioned my high leverage point, and the last thing to talk about here is what is the relationship in the context of the problem that you've seen. And we're really running out of room, so I apologize, but I think we can squeeze it in there if you've been writing small with me. If not, hopefully have some room above, and you can kind of maybe put an arrow. So I would say, as and this is what we already noticed, as gas mileage increases, or as speed increases, gas mileage tends to increase to a certain point, and then as gas mileage further increases past 50, gas mileage tends to decrease. So as gas, or no, we're going to do speed. As speed increases up to 50 miles per hour, gas mileage, keep spelling mileage wrong, but it's fine, mileage tends to also increase. Then as speed increases past 50 miles per hour, gas mileage tends to decrease. Awesome. So again, don't overcomplicate. And again, I've kind of just noticed the trends here. Notice I say tends to because it doesn't mean it has to. And I also say tends to somewhere else right here. So again, kind of noticing a trend. All you're doing when describing a relationship or writing about a relationship is talking about the strength, the form, and direction, commenting if there's any outliers or high leverage points, and then kind of just reiterating what the relationship is that you saw. So try not to overcomplicate, but it's good structure to get started. All right, we will see you in a bit.